Hey, AP Chemisters, this is Mrs. Vanderlei bringing you Chapter 3, Section 12, Organic Compounds. We're not going to go in a whole lot of detail, but just enough so that when you see organic compounds later on in the year, you have a basic understanding of what they are, okay? So organic is composed of carbons and hydrogens, or hydrocarbons, and other possible elements such as oxygen and nitrogen. Those would be your most common. Letter A is super duper important. Highlight this, star this, whatever. Carbon will always have 4 bonds. This will explain later why. Carbons can have single, double, or triple bonds. Carbon can be arranged in a ring as well. Hydrogen can have only 1 bond, never any others, okay? So really, this is your basic look of what carbon will look like. Now, what could happen with some of these electrons here? They're 4 valence electrons. These guys can make a single bond. You can bring this down and make a double bond, or you can bring this one up and make a triple bond, okay? So keep that in mind as far as organic goes. You have to have 4 bonds for carbon. That is super duper important, okay? Now, how do we name them? Okay, how do we name hydrocarbons if it contains only carbon and hydrogen? Your base name is determined by the number of carbon atoms, and your suffix, the ending, is determined by the presence of what kind of bonds, all right? So we'll do this part first, and then we'll do the second part. So let's scroll up here. Now, my high school chemistry teacher taught me Maria eats peanut butter. So what the heck does that mean? Maria stands for, so one way to remember that you have 1 carbon. Maria is meth. Eats is F. Peanut is prop. Butter is but. Okay, not but, don't say but. Those actually came from old terms, if you will. Has to do with what the original things came from, like, you know, methanol and things like that. But those prefixes have stuck around to mean 1, 2, and 3, and 4 carbons, okay? The rest of them should look really familiar. You've seen these before. Those are your covalent prefixes that we did in section 3.6, okay? So 5 is pent, 6 is hex, 7 is hept, oct, non, and dec, just like before, okay? The new ones are your meth, eth, prop, and but, okay? Let's turn the page. So the suffix, the root, will tell you the type of bonding. If you have all single bonds, carbon single bond, it's going to end in ane. It's called an alkane. And the general formula is CnH2n plus 2. So if you have 1 carbon, that's your N. So 2 times 1 is 2 plus 2 would be 4. So it's C1H4. If you have 10 carbons, that'd be decane. If N was 10, it'd be 20 times 10 plus 2, it'd be C10H22. Okay. If you have 1 double bond, it's an alkene. Okay, and the formula is CN2N, so you double it. If you have a double bond, you double the number of hydrogens, all right? Why? Because you end up taking 2 off from here to make the double bond. And what if you have 2 double bonds? Then it would be a alkadiene, diene, 2 double bonds. If you have 3 double bonds, it'd be a triene, and so forth. Alkyne is if you have a triple bond. So my chemistry humor, it takes alkynes. Get it? All right. Anyway, so that's your triple bond. And again, it's Cn would be your number of carbons, and then double it, and minus 2 would be your number of hydrogens. All right. So draw the following molecules. Well, first, before we draw them, we need to know the formulas. So remember, Maria eats peanut butter, meth. By the way, there is no such thing as methane or methine. You only have 1 carbon. And what did we say on the first page? How many bonds can hydrogen only have is just 1. So you can't have a double bonded hydrogen. You cannot have a triple bonded hydrogen. So in the case of meth, you can only have methane, okay? So meth means 1. So double it and add 2 is CH4. So that's going to be my formula. And now draw it. So all you have to do is draw your carbon and put your 4 hydrogens all around it. So that would be methane. So what about ethane? Why don't you take a minute out and come up with its formula? Okay, so pause this, come up with a formula. All right. Oops, sorry, that's not for you. Here you go. Here's the formula, C2H6. How did I do that? Took my 2, double it, and I added 2. So 4 plus 2 is 6. So watch here what I have. Whoops, that's not it. I have this one. There we go. And so here's my 2 carbons, and I have my 6 hydrogens around it. So again, why is it 2n plus 2? Because the n's are your plus 2. So there's right here you have 2 hydrogens for the carbon, here you have 2 hydrogens for the carbon, and then you have your additional 2 hydrogens as your n's, okay? So let's see about butane. All right, so why don't you come up with the formula, see what you get. Did you get this? I hope so. Go ahead and draw it now. Did you get this? Notice you have 4 carbons, you have 2 on each carbon, and then the additional 2 on the end. So it's your C4H10. Now look at number 4. It is 3-hexene. Well, first of all, what is its formula? Well, if you have 6 carbons, how many hydrogens do you have? If it's a double bond, you just double it. So what will its structure look like? Take a wild stab. Where do you think that your double bond is going to be? Well, look, I put a 3 here. So it's going to be on the 3rd carbon. Oh, oops. So if I have it, there we go. Notice 1, 2, 3. So I put the double bond between the 3 and the 4. And notice I took off the 2 hydrogens that belonged here. That's why it's 2n minus 2. All right, I'm sorry, wrong one. So it's just 2n. You took away if it was hexane, you took away these 2 hydrogens. Why did I have to take away those 2 hydrogens? Because remember, how many bonds must carbon have? It has to have 4. So if you look at this carbon, 1, 2, 3, 4, there's a double bond here. If I had kept the H here, then carbon would have 5 bonds. Can't do that. Can't have 5 bonds. Can never have 5 bonds, all right? Same thing with this one. Notice with the double bond, it already has 4 bonds, 1, 2, 3, 4. If I kept the hydrogen here, it'd have 5. Can't do that. So be very, very careful. So what did I tell you to star and circle and highlight? You can only have 4 bonds. Always check your work, okay? Let's see what we're doing in the next section. It says, name the following structures, fill in the missing hydrogens, and give the formula, all right? So let's do this first. 3 carbons. What's the prefix for 3? Maria eats peanut. What's peanut? Prop. All right, what do you know about the bonds? What do I see right here? They're both what? Single. So what is the ending for single? Ane. So this is called propane. What would be its formula? Well, if I have 3 carbons, double it and add 2, and you get 8. So why don't you go ahead and fill in your missing hydrogens? All right, you get 1 here, 1 here, 1 here, 1 here, 1 here. You get the idea. 1 here, this is hard to do, and 1 here, and finally the last one there. So how many did you put in there? 8. Good. Got it. So what about the next one? Look at number 2. How many carbons are there? 5. Are they all single bonds? Yes. So what is that? Pentane, for pentane. What's its formula? C5H12. You go ahead, and there should be 12 hydrogens around here. Make sure you got that. Now, do me a favor with number 3. There's, for some reason, at least my copy has some little issues. Make this a double bond and a single bond with 3 carbons, and make this a triple bond. It was missing. So go ahead and do that. Oops. And see how you do. Go ahead and name it, put your hydrogens in, and give me the formula. So take a few minutes out and do 3 and 4. So pause this. All right, so number 3, what happened? You have 1, 2, 3, so that's Maria eats peanut, prop. But now I see what? One double bond. So it's a propene. Now the question is, where is the double bond? It's off the first carbon. So it's one propene. Now, if you take organic, you realize I could probably leave that one off, but for right now, let's leave it on. What is its formula? C3H6. And what I would like you to do, make sure you draw your hydrogens. So I'm going to put how many here? 1, 2, 3. Now count. How many bonds does this carbon already have? 1, 2, 3. Excuse me. So how many of them must be hydrogens then? You need one more hydrogen. You can put on the bottom if you want. Just make sure you put only one hydrogen. Now, how many bonds does this carbon already have? 2 and no more. So how many hydrogens have to go there? 1, 2. So now count. You have 1, 2, 3, 4, 5, 6. Well, yes, you do. There it is. Okay. Go ahead and do number 4. All right, how do we do? 1, 2, 3, 4, 5, 6. Hey, what's the prefix for 6? Hex, you're right. And what else do we know? There's a triple bond there. So this is a hexyne, and where is it? On the first carbon. So now what is the formula? I have 6 carbons. 6 times 2 is 12. 12 minus 2 is 10. So that's my formula. And let's go ahead and draw your hydrogens in. So we have, I'm going to start here. 1, 2, 3, 4, 5. These have to be lines. 6, that looks better. 7, 8, 9. Now let's look at this one. How many bonds does this carbon have right now? 1, 2, 3, 4. Does this carbon get any hydrogens? No, no, no. It already has 4 bonds. So how about this carbon? How many does it have? 1, 2, 3. So how many hydrogens does it need? Just 1. So if you count all my lines, these are actually lines here. I'll make them a little better for you. All right, how many total hydrogens do I now have? I have 10, and that's all I should have. Okay. So let's talk about functional groups real quick. A functional group are a group of elements that will change the properties of the main carbon chain. So a functional group will have carbon, or excuse me, will have oxygens in it, will have nitrogens in it, maybe a sulfur in it, and so they will definitely change the properties. Like what? It's going to change their boiling points. It's going to change their attractions. It's going to change their ability to dissolve water, that kind of stuff. They're called intermolecular attractions. And so if I have an alcohol has an OH on it, okay? And this is really bad. I'm not making any kind of political statement here, but O kills OH alcohol. I don't know if it helps or not. But an alcohol is on a carbon. A hydroxide is not on a carbon, all right? A hydroxide's with another ion. Carbons aren't going to be that ion. So don't be confused between alcohols and hydroxides. They both have OH groups, but an alcohol has it on the carbon. The OH is going to be on, the hydroxide is going to be on a cation, okay? So for example, my CH3OH, how do I name it? Well, how many carbons are in CH3? Just 1, so that's your meth, single bonds and then I have the ending OL, methanol, okay? Carboxylic acids are another very important functional group for AP chemistry. You see you see, get it, the C. The carbon has a double bond oxygen and a single bond oxygen with the H in it. It is not an alcohol. The C double bond OOH is one functional group, okay? The additional oxygen will again change the properties of your basic chain. So if you look at the next one, how many total carbons do I have? Total is 6. I have 5 here and 1 more makes 6, so it's hex. All these are single bonds and then carboxylic acids and then oic acids. All right, so that's pretty much what you need to know for AP Chemistry. If you take organic, there are like 8 more functional groups you should learn. But for you guys, for what you need on the AP exam, if you know your basics, if you know your alcohols, if you know your carboxylic acids, you'll be fine. Let me show you one more thing. I go back a few pages. I can't seem to find it, but somewhere in our notes we were talking about C5H12 and I called it pentane. And now you know why it is pentane, okay? So that's it. That's all I have. So once again, don't wait to be great, and we'll see you next time. Bye-bye.